construction from a slightly different perspective and talk about resource allocation, resource leveling, network crashing, the cost of crashing, and the cost-time trade-off. Now, Module 6 would deal with some principles of quality management, where we'll talk about quality control, quality assurance, total quality management, quality audits, the cost of quality, ISO standards, and inspection. The discussion in this module would largely be related to construction projects. We must keep in mind, and I'm going to reiterate that when we come to this, as far as industrial systems are concerned, as far as production industry is concerned, where we are talking about manufacturing of cars, we're talking of any industrial product which is being manufactured in the industry, the concepts of quality and quality control are reasonably well developed. The issue is whether those systems are applicable to construction activities which are unique, that is, they are non-repeatable. They are done at site under completely open conditions where we don't have controlled environment. When we are constructing a bridge, it's not a factory condition. It could start raining sometimes, it could become very hot sometimes, it could become windy, and so on. So the issue will be that, okay, how do we ensure quality of construction under these conditions? Of course, we have a lot of information available from our friends in mechanical engineering, from our friends in industrial management, but we have to actually adapt those prescriptions or those specifications in our systems as far as construction projects are concerned. Of course, it doesn't mean that we don't have any methods or any protocols to ensure quality as far as construction is concerned, but we'll try to evaluate those issues as we go along in this module of quality management. Now, Module 7 would be safety management. We'll talk about unsafe acts and conditions, injuries, accidents, personal protective equipment, safety audits, role of a site engineer, the principles of safety, safety manual, safety plan, incentives, and OSHA. I'm not explaining to you what OSHA is. Try to figure out if you can. Otherwise, of course, when we come to it, we'll talk about it. The thought process that I have in including this module in this course on principles of construction management is that we must, as civil engineers or as engineers with any kind of affiliation, we must ensure that the construction activity is safe. It is accident-free. It does not cause injury or any kind of harm to the people involved in the project or people who are not involved in the project but happen to be passing by, or at the end of it, even the people who will use the project at the end of the execution. Now, it's very unfortunate that we often hear that a certain building under construction or a certain bridge under construction collapses. There are reasons for that, and those are exactly the kind of reasons which we must investigate. We must be aware of what could cause an accident and try to make sure that accidents do not happen. Accidents are accidents. Sometimes they will happen. They are unforeseen. They are unplanned. Nobody plans for an accident. But there has to be a method in which we will or we can control accidents, make sure that accidents don't happen. There have to be methods by which we can evaluate one company or another in terms of its accident record, in terms of its safety record. So these are the kind of things which we'll talk about when we go through this module on safety management. When it comes to legal aspects of construction, what will we talk about? Different agencies involved in the project. It could be the client, it is the designer, it's the contractor, it's the investor, it's the regulator, and so on and so forth. Now, if there are multiple agencies involved in the project, what should be the kind of documentation which will define the roles and responsibilities of each of them. And that is what is basically a contract. We must remember that these are large projects spanning over several months or years, involving hundreds of people, sometimes thousands of people. And therefore, unless there are written documents which define the roles and responsibilities, which define the kind of work they will do, it's very, very difficult to manage a construction project. That's one part of it. The second part of it is that there's a large amount of money being used. And we have to make sure that the money is being used in the best possible way, in the most effective way. There is no wastage of funds. And if there's any waste of resources by any of the stakeholders, there have to be ways and means of penalizing that particular agency. So all that part is laid down in contracts, and that constitutes the legal aspects of construction. And what we will be talking about is claims, disputes, arbitration, project closure, role of third parties, legal cell in a construction company, and labor laws. Now, labor laws is also a very important part of a construction manager's job. As a construction manager, one must be aware of the rules that govern employment of labor in terms of the facilities that they need to be provided, the kind of protection they need to be provided, the kind of facilities and so on. So this is what the course will contain. As far as assignments in this course are concerned, there'll be lots of assignments because obviously being a width course, we will not be able to cover many of the keywords that we talked about in any detail. So there will be just the definition given in this lecture, and then maybe we'll ask you to develop it on your own. So basically what I've thought is that we'll divide the assignments in this course into two parts. One would be normal assignments for submission, where there'll be grading and solutions will be provided, and we'll probably have a discussion in the discussion forum and so on and so forth. But apart from these assignments, there will be what I call type 2 assignments, which are basically food for thought and do-it-yourself kind of assignments, where there would be reading and self-learning questions, questions which I will give you and not answer them. Namaskar and welcome back to our lectures on principles of construction management. And today is lecture number 2, where we'll talk about the interdisciplinary nature of modern construction projects. Traditionally, construction projects were seen to be largely civil engineering projects. Now it's not so anymore, and that is what we will see through an illustrative example of metro construction. Now, before we get into a discussion on metro construction and the example and the issues involved and so on, let's go over the course once again. Urban built environment in the 21st century is focusing on various infrastructural aspects such as commercial buildings, malls, metros, airports, roads and rails. And accordingly, modern infrastructure projects are getting increasingly interdisciplinary or multidisciplinary in nature, in that they span several disciplines of engineering. So most of our treatment here will be with a civil engineering bias, but we will not try to use a lot of knowledge of technical civil engineering or the specifics of civil engineering, but of course we will have to borrow from civil engineering issues. As a manager of these projects, a certain level of awareness and knowledge of diverse issues is required. Needless to say, depending on the stage of construction of a project, the project manager could be from civil engineering with a civil engineering background, or it could be from a mechanical engineering background or an electrical engineering background, and so on. It's important to understand that in the construction phase, at different points in time, different activities are predominating. In the initial parts, there's a lot of civil engineering that goes on. As we go along in the project, perhaps depending on the nature of the project, mechanical engineering and electrical engineering, these kind of issues become more important. So organizations tend to change the project manager from time to time, depending on the expertise. Similarly, having said that, even when civil engineering activities are going on and the project manager is a civil engineering background person, that person should have a basic understanding of the mechanical and electrical engineering issues and so on. So that is what is the backdrop against which you should try to understand our treatment of construction projects. So now coming to interdisciplinary nature of projects, let's take some illustrative examples like metro construction or an automobile plant or even a transmission line project. So if we broadly divide the engineering domains as civil, mechanical, and electrical, of course there could be other disciplines also involved depending on the nature of the project, depending on the stage in which the project is, and so on. If it's a metro construction, there are definitely civil engineering aspects, mechanical engineering aspects, and electrical engineering aspects. Similarly, in an automobile plant, once the plant has been commissioned and is in operation, then it's not necessarily a great civil engineering operation. So it's a mechanical engineering operation with controls, electrical engineering, software people. All these people come into play as far as management of that operating plant is concerned. But at the time of construction, it is largely a civil engineering activity. In the case of metro construction, however, even during operation, the civil engineers continue to play a very important and a vital role. It's not only metros, but in fact, if you think about it, if you look at the railways for that matter, you will realize that even in the operating phase, the civil engineers have a very important role, but the training and the kind of skills required is not necessarily those required at the time of construction. At the time of operation, you require skills in non-destructive testing, monitoring, repair, and so on. The skills required is different, but the background is the same. Now, if you look at the third example, which is cited here, the transmission line project, an electrical company can decide to lay a transmission line from point 1 to point 2. There will be electrical engineering issues, of course, because what kind of power to be transported, what kind of towers to be used, what height the towers will be, and so on. Those are issues which need to be resolved in consultation with the regulatory authorities and so on. But once the electrical part of it is completed, the loads and so on are handed over to civil engineers for structural design and so on. There is the construction part where the towers are erected. And once the towers have been erected, civil engineers are obviously not the best people to identify the kind of wires to be used, the kind of fabrications to be done, or for that matter, the kind of laying of the lines is concerned, or substations on the way. The construction of the subway is a civil engineering issue, but the equipment that goes into the substation is definitely not civil engineering. So the project manager who manages these projects has to have some understanding of all the different facets of the project. So now getting back to our example, which we will deal today, is metros. So now, if you look at metros, we need to break it down. It would be easier if we break down a metro system into components and then try to see what kind of expertise would be required to manage or to be able to implement a particular part of the construction. So now there are different ways of looking at this breakdown. One is to look at what are the different components in terms of, let's say, the stations. So there are stations where the metros or the trains, they come, they stay there for a certain amount of time. And therefore, the kind of issues that go into the planning of a metro station would include movement of passengers coming in and going out, the movement of trains coming in and going out. If you look at the planning of stations, primarily the issue is movement of passengers embarking and disembarking, and how we will transport them from the outside of the metro area. So if you look at any metro station, you are approaching the metro station from an area which is not really metro. So first thing is that the passengers will come into the metro area, then they'll come to the platform and take the train. On the other side, people will disembark from the train, get out of the platform to the station area, and then leave the metro area. So one of the parts of planning and construction of stations is the movement of passengers. Similarly, there is this issue of trains which are coming in and going out. There is the related signaling issues and so on and so forth. In both these cases, there have to be appropriate provisions for safety measures or emergencies that may arise. So if there's a fire in the station, there have to be emergency evacuation systems in place and so on, and that goes into the planning and construction of stations. Moving from there, there are maintenance yards where the coaches and the locomotives are maintained. That is, they are overhauled, some kind of minor repairs are carried out and so on. So again, if you look at the movement of trains, so the trains move on tracks which are laid on sleepers, and the load is then transferred to the ground. So apart from the coaches and the engines, everything is basically a civil engineering domain story. Whether it is the tracks, whether it is the sleepers, whether it is the ballast or whatever goes on in transferring the load to the ground. So as far as a maintenance yard is concerned, depending on where the maintenance yard is, somebody will tell you that, okay, this is the length of the trains which need to be parked so that they can be cleaned. But the layout and the civil engineering infrastructure that goes, water supply there, removal of wastewater from there and so on, that remains a civil engineering domain issue. Similarly, if you look at operations rooms and offices, so there is the need for having operations rooms, offices where different people associated with the metro operations will work from. And that has to be, again, planned. Continuing with the story, there could be tracks. And now if you just pause to think about some of the metro systems that you may have seen, you would realize that the tracks could be underground, or they could be on grade or above grade. Now, depending on whether the tracks are underground or on grade or above grade, different aspects come into play. And as engineers, we need to understand the issues so that we are able to handle them as they come during design or during construction. Proper understanding of all these things helps us plan the system better and ensures that as we go along in a construction project or in the project of metro construction, we do not have to make sudden changes. Another way of looking at some of these systems would be, let's try to divide them into civil structures. Now, if you look at civil structures, there could be buildings, operations rooms, and stations can all qualify as buildings. Similarly, there would be tracks, there would be tunnels. If the track is underground, we'll have to make tunnels. There would be bridges. Now, bridges can have two functions here. One would be crossing a river or any other obstacle. The other way of looking at a bridge would be all kinds of track which are above grade. They could also be looked upon as bridges in one form or the other. So depending on what view we take, these are basically inclusive of all kinds of above grade structures which are designed to carry the metro above ground. Then there is rolling stock, which is definitely not a civil engineering story, and that consists of coaches and the locomotives. And besides that, there are controls and monitoring systems. There is the entire power network which has to be laid down, and so on. So depending on which way we break down a particular system, we'll have a better understanding as to what is the kind of expertise which is required for executing a project. Now, execution of the project does not necessarily mean only on-site operations. If it comes to rolling stock, for example, these coaches and locomotives have to be procured. When it comes to buildings or tunnels, we need to decide what kind of material we will use. And that decision is also an engineering decision and needs to be taken with proper planning and technical issues being kept in mind. Now, here is an example of a station. And you can see that apart from the train and the platform, there are so many other things which are a part of the station. There are signages which tell people which way to move in case of an emergency, which way is the exit. There are signages to tell people how much more time to the next train. There could be signages relating to whether a train will stop at that station or not, what is the next stop for that particular train coming into the station, and so on. So all these things need to be properly planned, included in a drawing, which is used for communicating among engineers from different walks of life. Similarly, if you look at a maintenance yard, here is a place where you would need a lot of water supply, a lot of systems to make sure that certain amount of testing can be carried out. So now here is a maintenance yard where you'd need facilities which are required to maintain the coaches and the locomotives. That could include water, that could include some amount of power. That would definitely need some amount of lighting depending on where the yard is, and so on and so forth. In operations rooms and offices, of course, you need a different setup, and that needs to be planned. When it comes to an underground track, which is essentially a tunnel, we have to understand what are the issues that go into the planning, design, and construction of a tunnel. That would include things like lighting, ventilation, emergency communication, the kind of slopes that you have to have. You have to make sure that there is no leakage of water from outside into the tunnel. What are the kind of emergency evacuation plans from the tunnel, and so on. In fact, it's sometimes important and required that along with the tunnel, we run what is called a service tunnel, which serves as a parking space or which serves as a place where people who may have to evacuate from a train in the case of an emergency can leave the tunnel and assemble in a service tunnel. The service tunnel also serves as an area through which service lines such as water and power run in addition to the space within these tunnels. When it comes to an above grade track, of course, the situation is more or less similar to that of a bridge, and you can see that we have the standard bridge piers and the slab and so on, which is designed for the kind of loads that is to be carried by the structure. So now other components in a metro system would include power supply, signaling, ticketing. We have to make sure that there is no rush of people at ticket counters and at places where there are wickets to check the tickets when the passengers are coming in and the passengers are going out. Then there is a very important component of emergency management. It could arise on account of power failure. It could arise on account of a terrorist threat and any kind of an unforeseen event. It could arise on account of an accident where a derailment has occurred or where the trains have collided, and so on and so forth. Apart from these, now once we are talking of these things, like I mentioned, there are issues related to lighting, ventilation, communication, air conditioning, and power supply, besides firefighting. All these plans have to be put in place so that the metro system can be designed. Now, it's no single engineer's cup of tea to be able to put together or have all the knowledge that is required for lighting and air conditioning, communication systems, and so on. So different people come together, form a team, and carry out this exercise of planning and designing a metro system. It could be stations, it could be the track, it could be the control room, it could be the maintenance yard, and so on. So now, coming to the food for thought, this is a type 2 assignment, as I said. We'll probably not give you a solution because there is no solution to it. Find out the different cities in the world with well-developed metro systems. Now, in this day and age, where information is not really at a premium, you can get information from a lot of sources. It's easier to find information. The more important issue, or the trickier part, is analyzing that information and using it to understand the subject matter of the system better. So if we look at places like Tokyo or New York, London, Moscow, which have well-developed metro systems, now of course we can include Delhi in that list. If we try to understand, look into the history and find out when were these systems built, what was the kind of technical issues addressed and how, that will make us understand the roles of different engineers better. The second question that I want to leave for you is study the details of the metro system in any 3 cities, which could include important stations in the network. Delhi may have a certain number of stations. If you look at the Tokyo metro network, you'll find a certain number of stations. If you look at the New York metro system, you'll have a different number of stations. And the more the number of stations, the more the number of lines, the more complex the system becomes. And that makes the planning that much harder. Have you ever thought that when we change lines at a particular platform, how do those lines go? So for example, if we are talking of a line which connects point A to point B, and a line which connects point C to point D, how do these lines actually go as far as their layout is concerned? This here, as far as the roads are concerned, we can easily have a crossing. We can have traffic signals to control whether the traffic is moving between A and B or the traffic is moving C and D, and whether the left turns are allowed, right turns are allowed, and so on and so forth. When it comes to metros, those kind of degrees of freedom, if you want to call them, don't exist. But how do the lines cross? The lines will cross means that there have to be tunnels, or it will be a grade separated system. And if it's a grade separation, what should be the minimum clearance? So these are the kind of things which are technical details we have to keep in mind when we try to do the layout planning of a metro system. So I would like you to pay special attention when you try to study the metro systems in different cities as to what are the kind of depths involved in these lines. The thumb rule basically is that if the line is very shallow, the line was probably one of the earlier lines that was built in that system. As we moved in time,